Hi students, I hope all of you are fine and sound, including your family members. So as you know students, this COVID-19 has created a situation which is getting from bad to worse. But as mankind, we need to find a solution for this, and we have always found a solution. Mankind have always found a solution for their problems. So right now, completing the second PU syllabus, that is the problem for us. And right now, here we are here to find the solution. Okay. So what all this shows to us is that studying science, okay, people who have studied science before, because of that research, that study, today we have the technology to record this video and audio and transmit it to our students. So here it shows the importance of science. Okay, why science is important, why people should study science, why government should put money in research, okay, so that development in science becomes very important. Another thing is, uh, right now we are looking for the vaccination, right? So we are of course in depth of the doctors and the nurses and the staff members who are putting their effort, who are putting their risk in their life in the risk to save mankind. However, the researchers who are doing the research to find the vaccination, they are also playing very important role, isn't it? Right? So in order to reach that stage, you need to learn about the basics of science, which is taught in schools and then in pre-university. So I hope all of you will be interested in this. I hope you got the message that science always leads to development in technology, which in turn will save mankind in such situations which we are facing right now. Okay. So having said that, let us not waste too much time and start the second PU syllabus. So let me try to compress the whole second PU syllabus in a nutshell. Okay. So first chapter that you will study is called electric charge and fields, and the next chapter is called potential and capacitance. Both of them come under a unit called electrostatics. So first we'll study about what happens when a charge is at rest. Charge is at rest. Okay, what effects the charges will create. Okay, then in the next chapters, third, fourth and fifth, we are going to allow the charge to move. Okay, so when the charge will move, you know you get current. Okay, so the charge which is at rest, we say creates something called electric field. The current creates magnetic field. We write the symbol B for historical reasons. Then when this charge will not just move, but it will accelerate. Okay, moving is of course, to accelerate you need to move, but if you move uniformly in a straight line, then there is no acceleration, right? So if the charge accelerates or oscillates up and down, that is a beautiful example of acceleration, right? Then you get something called electromagnetic field, which we call electromagnetic waves. Okay, then we study about light, and then we realize that light is nothing but electromagnetic waves. Okay, then so the first volume of first PU from chapter 1 to chapter 8 or 9, I think, from electric charge and field up to EM waves, the first volume is up is the study of this part. Okay, so first we'll study what effects charges at rest they create. Okay, so the effect basically comes through something called electric field, which we'll discuss. Then when the charge moves, it creates a magnetic field. When the charge accelerates, we come to know that there can be a, a uh, what should I call, not superposition, but a mingled up, okay, a mixture of electric field and magnetic field, and that we call as electromagnetic waves. Then the second volume, the ninth chapter, starts with study of light. Then in the 10th chapter, we come to know that light is electromagnetic waves. It has to be electromagnetic waves. Then we will realize that, oh no, in certain experiments done by Hertz, explained by Einstein, which you have studied in class 11 chemistry, that light can sometimes behave like particles, like potatoes and tomatoes. Okay, so that we study later. Okay, so we come to know that light can have particle behavior. Okay, so that we call it as dual nature. Why? Because previously we have shown light behaves like waves. Then we are saying that in certain experiments light will behave like particles. Okay, then we ask the question, when are these particles of light, which is called photons, when are these photons emitted? So these photons are emitted, we come to know, when electrons in an atom makes a transition from higher energy level to lower energy level, and therefore we start studying about atoms. Then we dig inside atoms and we come to know that, okay, why is electron going around the, no, it's going in circle. If something is going the circle, it needs a force towards the center. Like in the case of Earth, the sun provides that force through gravity. So here also we need to have something at the center, and that we come to know is nucleus. And then we go deeper in the nucleus and study about the phenomenon of nuclei. Okay, what nuclei does, how it decays, what kind of reactions happen. Okay, then we bring all these atoms together and we form a solid. And we are not going to study any kind of solid. We are going to study that solid that revolutionized the whole technological technology, right? Through the creation of transistors, amplifiers, and today we have laptops and computers and mobile phones, right? So that we study through a chapter called semiconductors. So when these atoms come together, they form a solid, and that solid, the important class that we study is semiconductors. Let me write the full spelling. Okay? Semiconductors. Semiconductors. Okay. And then finally, the last chapter, there is a, like this year, the last chapter which was there previous to this year was communication system. So once you make that transistor and amplifier, how do you use it to transmit radio waves, which is again one of the EM waves, to transfer information from one place to another place. And that chapter falls in the communication system. But there is a slight confusion regarding this chapter, is still there in the syllabus or not. It's not visible, right? So communication system. So in a nutshell, this is your second PU syllabus, entire second PU syllabus. Okay, so you can just go through it once. Fine. So once we have understood what we have to do, let us start with the first chapter. So the first chapter is called Electric Charge and Fields. Okay, so we will study about what charges at rest. See, the moment I say at rest, it is always with respect to some frame of reference, right? So those are topics of first PU. So we are going to study electric charge and fields. Okay. So here the important thing is to master this concept. Very, very important. Okay. So the field concept is very important. I will be trying to explain to you everything that you need to know about fields. Okay. But before we go into fields, let us study what is electric charge. So the obvious question is, what is electric charge? What is electric charge? Okay. So unfortunately, this question does not have a answer actually. Now, if it doesn't have an answer, which means we don't know about it, then what are we doing with this topic? Well, in physics, there are certain quantities which we call as fundamental quantities, and other quantities are understood through those fundamental quantities. We do not have more fundamental quantities to understand this fundamental quantity. So what is charge? Let me put it the the definition per se which we write in textbooks. But again, I would still argue that that's not what is charge, because we really don't know what is charge. But what charge does, we can tell. Okay, so what is charge is, it is an intrinsic property. Okay, so charge is an intrinsic property. Now, intrinsic word means what? Intrinsic means something, some property which the particle, which the object always has. Like, for example, if Pankaj sir is there, then his mass will always be there. So I cannot be there without my mass. Okay, so mass is an intrinsic property of objects. Cloth is not intrinsic, obviously, right? Similarly, charge is an intrinsic property, meaning of what? Of certain particles. Of certain particles, not all the particles in the universe, certain particles. Examples are like electrons, protons, right now, that these are the particles which you may be knowing. So charge is an intrinsic property of certain particles, due to which they are able to exert, electrical force, electrical force between them. So if you see, we are not really saying what is charge, we are saying what charge does. So charge is an intrinsic property of certain particles, okay, due to which they they exert electrical force between them. So this is one technical word, electrical force. This is one technical word, charge. So what is charge? Intrinsic property of certain particles due to which they exert electrical force. What is electrical force? It is the force which comes due to charge. So to define this, I am using this. To define this, I am using this. So this is a circular definition. Is it clear? So which actually means you don't know both. Okay. However, the good news is we know what force is, right? And there are, in first PU we have studied some fundamental forces. Okay. So the first one being gravitational force. So we know that this pen, if I leave, it falls down, right? So that's because there is a huge mass below, which we call Earth. So it is the source of this gravitational force is mass. Similarly, people did experiments in the long back, like in the 15th, 16th century and all, and they found that when you rub ember, now I hope you know what is ember. Okay, so if you, there's a tree called ember tree. Okay, if you put a knife, some liquid will fall, resin will fall. If it solidifies, it becomes transparent, not actually transparent, translucent orange color object, yellowish color object. Okay, and in my village, what the ladies will do, they will take these stones, put holes in the middle and put a thread, and then they'll wear it as necklace. Okay, so if you rub this ember, okay, with some cloth maybe, okay, and then bring it near to some dry leaves, you will see those dry leaves are getting attracted. So if you take ember and rub it on some cloth and bring it to near dry leaves, okay. So usually in childhood days, what we do is we take a scale, okay, plastic scale, we rub it on our hair, and then we bring it near pieces of paper. Then the paper is attracted. So from rest, it starts accelerating, which means from Newton's second law, there must be a force. But that force is clearly not gravity. That force is clearly not due to mass, because mass this scale had before also. So if it was due to mass, it should have attracted. Anyways, there is Earth here below, right? So Earth's mass is way larger than the scale's mass. So why would the paper be attracted to the scale instead of being attracted to Earth? So this force is not a gravitational force, but it is what we call electrostatic force. Electrostatic force. Okay. So now by comparison, if gravitational force is because the object has mass, electrostatic force we say is because the object has charge. And by rubbing, the scale got charged, we say, it got electrified. How exactly that happened, we will be studying in detail as we continue. Okay. So I hope you got the idea that charge is some intrinsic property of certain particles due to which they are able to exert electrical force between them. Okay. Now, uh, I told you it's a fundamental quantity. Now you may be thinking that in first PU, when we study about fundamental quantities, we write current as one of the fundamental quantity. We don't write charge. So it's one of the very good questions in interviews. If you go for some jobs and all, they may be asking this question to you. So instead of answering you now, I would like to keep that as a question for you. And in the next video, I will answer. In the meantime, you think about it. And if you get the answer, you can comment and I'll see whether it is the right one or the wrong one. Again, the question is, charge, I said, is a fundamental quantity. It sounds very much fundamental, you see. Okay, it's in the beginning of a chapter, right? So it is fundamental quantity. But when we write fundamental quantities, okay, in first PU, we don't write charge, we write current. So try to think why this was done. Okay, that's the first question for today. I'll be giving you two questions in my mind. I have conceptual questions. So this is one of the questions which I want you to think. Okay, so in physics, there are many quantities like this which are fundamental, but therefore we don't have a definition of those quantities in terms of more fundamental quantities. For example, what is time, if I ask? Because if you see dictionary, time says, if you see a dictionary, time says it's a period. Okay. Now, if you see period, it is what? Interval of time. So to define time, we need period or duration. To define duration or period, we need time. Again, it's a circular definition. So in physics, we really don't worry so much about defining fundamental quantities because we don't have more fundamental quantities, right? Instead, what we do, we try to measure these quantities more and more precisely. So today you must be knowing that uh, we can measure time up to this resolution, 10 to the power minus 23 seconds. So it's a huge achievement. This is done by using atomic clocks. So once we know that, okay, we are very much happy. We don't worry about how it is actually defined in terms of more fundamental quantities because we don't have. Okay. Uh, you must have heard that these days, mass, though we say it's fundamental quantity, but mass has been understood nowadays through a set of new particles called Higgs bosons. Okay, so that is again research level. If someday I get time, I would like to make a nice presentation on that topic. Anyway, so let's continue. So we understood till now that charge is a property of some particles because of which they can exert electrical force. Okay, in comparison, you can compare it with mass. Mass results in gravitational force, charge results in electrical force. And here I gave you an example that when you rub certain objects, the object gets charged. So why is it so? Why is it so? Again, before going to that topic, let us understand one very interesting difference between mass and charge. Mass is has only one flavor. Okay, flavor I say, matlab it is always positive. Charge on the other hand, it comes in two flavors. Okay, it has two flavors. Okay, how we came to know about this? It's a very interesting thing. So let us uh, do the experiments which made people understand that there is actually two kinds of charges. So what you do is you take a, let's say, plastic scale, okay, and you rub this plastic scale with let's say wood, okay. Then when you bring another plastic scale here, okay, rub this also with wood. When you bring this together, you find that these two repel each other. They repel each other. The moment you let them free, they repel. Okay. So before they were not repelling. Before, okay, when if you just keep them without rubbing, but once wool is rubbed on the plastic, wool is rubbed on this plastic, when you bring them near, they repel. Meaning they acquired some new property because of which they are able to repel each other. And that new property already we have called what? Charge. So let us say that this has property charge, let's call it charge A. Wool rubbed with plastic. Here also wool is rubbed with plastic, so same property, charge A. If you like some other name, you can write Tom, charge Tom, like something, any name you can give, right? Then you do another experiment where you bring a glass scale or rod, and you rub it with silk. You rub this with silk. Bring it near to another glass, rub this also with silk. Okay. When you bring them close, again you find they repel. Now, if you are the first guy to do these experiments, then you will come to know, okay, here also due to the property of charge A, which I called A, they are able to repel each other. Here also they are repelling each other. So as a scientist, you will say this also acquired a new property, which is charge, and the kind of charge I am calling it A. However, if you bring plastic rubbed with wool and then you bring silk rubbed with glass rubbed with silk, okay, you should see before doing this experiment as scientists you should make a prediction. So you made a theory based on these two experiments that when you rub plastic with wool it acquires a property which we are calling it as charge A. And here also it was repulsion, so we called it same property charge A. So now what law you made? You made a law saying A repels A. Charge A repels charge A. And experiments are there to suggest, right? But when you do this experiment, what is your prediction? Plastic with wool, which property? A, charge A. Glass with silk, which property? Charge A. So A and A should repel. But when you do the experiment, you find that they actually attract. They actually attract. So that means that this property cannot be same as this property. So you have to now redo your theory. You have to undo your theory, solver change it. So this becomes now charge B. And now your law becomes A repels A, B repels B, whereas here A attracts B. Understood? So this is how we come to know that charge comes in two flavors. Here I called it A and B, but the guy who did this kind of experiments was Benjamin Franklin, and he called them positive charge and negative charge. So anyone you can call positive charge, the other will become negative charge. Okay. Now, once we have a feel that yes, charge comes in two flavors, positive charge and negative charge, let us continue. Okay. So the next thing we would be discussing is something called Goldleaf Electroscope. So what is this Goldleaf Electroscope? It is a device which is used to detect charge. It's a device which is used to detect charge. Okay. You can make it in such a way that you can measure it also. But right now, let us say it is used to detect charge. So what it is made up of is there is a conductor, like a spherical conductor, and here also there is a conductor. Okay, and there are two thin foils of gold. Okay, so thin foils. Okay, that thin sheet of uh, gold here we use. Okay, gold is highly malleable. Okay, so we can make it into thin sheets, yet it will not crack. Okay, and then we put here some glass chamber so that air current doesn't move this. Okay, now suppose you take a object and you want to check whether it is charged or not. So what you should do, let us say this is positively charged for the time being. then what you do, you bring this in contact with this. If it is conductor, then the charge will spread all across it. Details I will be discussing. Okay, so the charge will spread, the whole thing will become positive charge. That's why it's conductor, right? It conducts the charge. So therefore, this foil now, both the foils are positively charged, so they will repel. They will repel. And that repulsion is a proof that this body is charged. Understood? Okay. What if I bring a negative charge and keep it on top of this, or negative charge here and keep it on top of this? Then that negative charge will make this less positive, right? So the divergence will decrease. If this negative charge here is equal to the positive charge, then it will completely neutralize. So the gold leaf will come back to its initial configuration, right? So this divergence of the gold leaf tells you about uh, how much charge is present. So more charge is present means more divergence. So you can also compare, you can detect charge and you can also compare this body has more charge than other body, which basically means you are doing measurement, right? Measurement means what? Measurement means you are comparing the given body with a standard body, right? So we give you a bag of potatoes, I ask you what is the mass of this bag of potatoes, you can't tell the mass of this bag of potatoes is same as the mass of this bag of onions, right? You need to measure it with some standard 1 kg stone or 2 kg stone, whatever it is called, weights and loads, right? Okay, so this is what Goldleaf electroscopes are. They are useful to detect charge. Now we will ask, how does or why does a body get charge? So origin of charge. To study the origin of charge, you need to know that every matter is made up of atoms, and again all these details will be taught in atoms chapter. However, from school knowledge and from the subject chemistry, you know that matter is made up of atoms, but in physics it will teach you in later chapter, okay, in second volume, probably 11th chapter. Okay, so once we learn that yes, matter contains atoms, and inside atoms we have this nucleus which is positively charged, and then we have this electrons which goes around the nucleus. Okay, so this is called the Bohr's model of atom. Bohr's model. Okay, Bohr's model of atom. So this is the picture of an atom. So when you now, an atom as a whole is neutral. Atom as a whole is neutral. So if you take carbon for example, there are 6 protons and 12 minus 6, 6 protons and 6 electrons, right? So this is the number of protons, and if the atom is neutral, that means in the nucleus there are 6 protons. So outside there will be 6 electrons. Okay, so that means the total charge of an atom is 0 unless we remove the electrons. Okay, so once we know atoms are neutral, an object which is made up of atoms will also be neutral. Okay, so if you take a matter, suppose you have body A and you have body B. Okay, so this is made up of atoms, this is also made up of atoms. Each atom here is neutral. Each atom here is neutral. Now when you bring them in contact and do some rubbing, okay, when you rub them, then what happens? Because of the forces created, the frictional forces, what happens is the electrons get transferred from one material to the other material more than from this material to this material. Now why would that happen? Think about this. Why would electrons only transfer and not protons? Because protons are deep in the nucleus. They are being holded by forces called nuclear forces, which are the strongest forces. So your rubbing is not going to affect the protons which are in the nucleus unless the temperature is exceedingly high, like in the sun. Okay, so if the temperature is exceedingly high, then even the nucleus can break. However, normal situations, when you rub two objects, it is the electrons, the outer electrons, which are going to get affected, right? Now, there is something called electron affinity, which basically tells you how much a material loves electrons. If I simply use a rough language, okay? So what happens is when you rub two materials, the object which has more electron affinity will take more electrons than the other one. Therefore, this body will have more electrons than this body. Now, from your previous knowledge, you know that electrons have negative charge and protons have equal positive charge. Okay. The charge of electron was measured by somebody called Millikan through an experiment called oil drop experiment. About this again I will be teaching you in the atoms chapter. Okay, so what was the experiment, how exactly it was done, so all that measurement part will be taught in the uh, later chapters. Okay, however, you should know right now the charge of electron in magnitude is 1.6 into 10 power minus 19 coulomb. Coulomb is the SI unit of charge, and we know that charge comes in two flavors, positive and negative, and historically it was decided that the electron will be given negative charge. Okay, so let me write like this only right now. So E means this much. Okay, so when I write charge of electron, I will write minus E, and when I say charge of electron, not electron. So charge of electron is minus E, and charge of proton would be written as plus E. So just like pi is a number, okay, E in this chapter will represent a number which is 1.6 into 10 power minus 19 coulomb. It will represent the size of the charge of electron or proton. Sign you have to remember yourself. Okay, fine. So what happens when you rub them? You know electrons will get affected. Initially, if I say this has got, for example, 100 electrons and this has 100 protons, total charge is how much? 0. Yes or no? And here also, if it is, let's say, 100, here so 100, let us assume, then total charge is here also 0. But when you rub, let us say B has more electron affinity, and what happens? Some electrons will be transferred this way. So let's say 3 electrons were transferred this way. Then this will have now 97 electrons only, because 3 electrons got transferred. This will have 103 electrons. So what will be the charge of this now? Plus 100 E, which is the charge of this 100 protons. Remember, charge of one proton is plus E. Charge of 97 electrons is minus 97 E. That will give you plus 3 E. Similarly, this will be what charge now? Minus 3 E, because this has got 103 electrons. This has got 100 protons. So a body gets positively charged not because it gained protons, mind you. It became positively charged because it lost whatever electrons it had when it was neutral. So something very important. A body gets charged when you lose your old electrons which you already had, or when you gain new electrons from other body which you did not have. So remember again, a body gets charged when you lose the electrons which you had, or you gain new electrons which you did not have. Keep this in mind when you were in neutral. Okay, so keep this in mind. Okay, so this is how we understand it. Okay, when you rub, electrons get transferred depending on the electron affinity. Now in our EPL, in the I think, let me tell you the page number. So it is in the third and fourth page. We have something called triboelectric series. Triboelectric series. Okay, let me mention here. Triboelectric series. So this series has been developed, okay, of course through experiments, and almost any kind of material we have made a list, okay, all kinds of material, and when you go down in that list, the electron affinity increases. So if you take any two, so here is one material, okay, different materials and names are mentioned. Names of different materials are mentioned. So as you go down, the electron affinity increases. So if you take this material and this material, and if you rub them, then this has more electron affinity, so this will become negatively charged and this will become positively charged. Fine, okay. So once we have understood this fact that okay, because of this transfer of electrons a body gets charged, let us now see what how a body can be charged. Okay, so there are basically two methods of charging a body. So methods of charging a body. In some books they write three methods. Okay, I will be mentioning all of them. So methods of charging is, one is by contact and one is by no contact, or something called by induction. So induction means no contact. Okay. So by contact, if you want to charge a body, then there are two ways to get here. Okay. So one is here you also have something called by rubbing, and then you have one by conduction. By conduction. So by contact means by rubbing or by conduction. That's why people say there are three methods: by rubbing, by conduction, by induction. In induction, there is no contact between the two bodies uh, through which you are trying to charge the body. Okay, so if you want to charge this body, you are not supposed to touch the body, okay, with the charge body, but still you have to charge it. So how we are going to do that, we'll study it. So by rubbing happens with insulators, okay, insulators, and by conduction happens with conductors. So let us quickly differentiate between these two materials. Obviously, you must be knowing by now. So conductors means a body which has large number of free electrons compared to insulators. So insulators have more or less no free electrons. Conductors have large number of free electrons. Okay, large fraction of the electrons are actually free. So therefore, the charge can be conducted through those free electrons. Okay. So in conductors, you can allow electricity in a way to flow. Charge you can make it flow. Whereas in whereas in insulator, charge will not actually flow through the material. So by rubbing, actually we have discussed before. So if you take two neutral objects, okay, both insulator, and you rub them, one will get charged. So whatever charge comes in insulator, it will stay there. So if this is positive charge, it will stay there. Why? Because it is insulated. The charge will not run through the material somewhere else. Okay. Whereas in conductor, once you charge the body, so you have a conductor, let's say, this is a conductor, okay, and you bring another charged body, positive, okay, then what happens is this positive charge will now be conducted through this conductor, and then it will get charged this way, because this will become slightly less charge. Okay, so let me try to draw once more. So suppose I show here 6, okay, then basically let's say here some of them will come here, let's say 4 of them come here, and this we still have 2. So why this happens is because of something. See, details again, as we keep studying about potential topic, okay, then details will be understood, but again you can understand this through an easy way also. See, electrons do not like electrons. So if you bring electrons very close, they don't like it, obviously, because we have studied that like charges will repel. So positive repels, negative repels. So when you bring these electrons near, they don't like it, right? So they want to stay as far as possible. Now if the material is insulated, they have no option but to stay there only, because it is not conducting, it cannot be transferred. But if you give a conductor and if you charge it at a given place, the electrons or whatever charge is there will have option to go as far as possible. Imagine there are a group of people in a certain room, and they want to go as far as possible, neglect about gravity, everything. Then what will happen? All those people will spread on the outer surface of the room. So that is as far as possible they can go. Okay, so that is the main idea. So before, if this was a conductor, all the charges were staying there. But once you bring them in contact with another conductor, then they have this surface now, this surface to spread. So they will obviously choose that uh, configuration more than this configuration, because they don't like each other right now. In this way you have to understand. Later when I speak about potential, you will get more clarity. Okay, potential is the reason why charges flow actually. Okay, just like temperature is the reason why heat flows. Temperature difference actually I should say. Similarly, potential difference is the reason why charges flow from one place to other place. But right now, to understand this simple, uh, to understand this concept, you can use a simple idea that like charges repel each other, and therefore, given an opportunity, they will try to go as far as possible. Fine. So by rubbing we have understood, by conduction we have understood. Okay. So let us study this through an example. So if you take a scale, okay, and you rub it on your hair, it will get charged. So let us say it gets positively charged. And since it is insulated, the charge will stay there. Okay. Now, by the way, I'll come to that later. Now, when you bring it to pieces of paper, these pieces of paper, now mind you, they are neutral. These pieces of paper were not rubbed, understood or not? So when I bring this scale near to these pieces of paper, we have learned that it gets attracted. It gets attracted. Now the question is, Arey sir, you told positive charges will attract negative charges, but these pieces of paper are neutral. So why it is getting attracted? Well, the subtle point here is what happens is when you bring this plus positively charged body near to these pieces of paper, whatever negative charges are there here will be solved by attracted dead set. Okay, so if you have an atom, here is nucleus, here is electron. When you bring a positive charge nearby, okay, so here is the nucleus, here is the electron. When you bring a positive charge somewhere here, the electron tries to stay more time there. Okay, it stays there more time. So the whole orbit in a way shifts. Okay, so that way, if it happens for each atom, what will happen? This side will become ಸ್ವಲ್ಪ negative, slightly negative. Okay, and this side will become slightly positive. Simply this side will become slightly negative, this side will become slightly positive of the pair. So this plus will attract this minus, and this plus will repel this plus. So why are those forces not getting cancelled? Because this minus is nearer to this positive charge. So this attraction will be more than this. Therefore, there will be overall there will be an attraction, because if this is 100, this may be, let's say, 60. So there will be 40 Newton force in this direction. These numbers are just for explanation. Okay, don't take them seriously right now. Okay, so I hope you understood. This is how this body got charged through uh, rubbing, okay, or you can say through by friction. These two are not charged. Remember, mind you, I have not charged these two. I have only separated the charge. When does a body get charged? I told you, a body gets charged when you lose or gain electrons. When you lose your old electrons or when you gain new electrons. So this paper is neither it has lost or gained, but only we have separated the negative charge and positive charge. This phenomenon is actually has a name. It is called polarization. Okay, later we will see in detail about this. So this example I wanted to tell you. Now, how did you make this positively charged? By rubbing it on your hair. Can you do the same thing with a conductor? Suppose you take a conductor, okay, let's say a spoon, metallic spoon, and you rub it on your hair. So this is your hair. Okay, will this get charged? Okay, of course you are holding it, right? So you are holding it with your hand. Okay, see, my diagrams are always funny. Okay, so you have very long hand, let's say. Okay, so you are rubbing it on your hair. Will this get charged? Think about this. Okay, so this is your foot. Okay, and this is ground. This is ground. You must be standing somewhere, right? Okay, will it get charged? The answer is no, it doesn't get charged. Now why? Let's say by rubbing some positive charge actually came, but this is a conductor. Human body is a very good conductor. Human body is a very good conductor. That's why you get electrical shock, right? When you put your finger through the socket, or when by mistake you put your fingers in water. You know, it used to happen to us. Okay, so in our place Shillong, We used to boil water through wires wrapped around some stick, and we used to put that stick inside the water and connect the wires through a plug into the socket. And as electricity will go, the water used to get heated. So to test whether it is hot or not, we used to forget to switch off and put the fingers, and electricity would run through us. So so human body is conductor, and ground is a fantastic conductor. So if you remember, few minutes back I told you, when a charge would not want to stay close by. If there is insulator, they can't help it. But if you give them a conducting surface and they have the option, they will go as far as possible and spread on the entire outer surface of the conductor. So when you give this opportunity, then what happens? This positive charge, why it will stay there? The whole charge will run to the conductor. Now you may be thinking, why is a little bit charge may be there? Earth is a huge conductor. So that little bit of charge will, once it spreads on the entire outer surface of Earth, the remaining charge is minuscule. So no charge basically will be left. So remember that. By the way, this concept of connecting charge conductor and running it through ground is called grounding. Very important in electricity chapter. Again, we'll be studying this in detail as we go. Okay, fine. Now, so we have learned charging by rubbing and charging by conduction. In both cases, we need contact. Now we will learn charging by induction. This one I'm doing it separately because this is a bit interesting also and ಸ್ವಲ್ಪ tricky also. Charging by induction. So let us see how do we charge a body by induction. This one I will be doing. The next one I will be giving you as your homework. Okay. So imagine you have a conducting body, which I'm calling it A, and this is insulating stand. Insulating stand. Why? I'm going to charge this body. Okay, so I don't want the charge to run to the ground. Okay, so I did some insulating body so that the charge stays here. Now I bring some charged body, positively charged. Okay, let's say a scale which is rubbed. No contact is allowed, mind you. No contact. Okay, so let us see what will happen. The moment you bring this positive charge, this is a conductor. So it has got large number of free electrons. So the free electrons get attracted towards this side. So this side becomes negative, and this will be having deficiency of electrons, those free electrons. So this side should be positive. Okay. So as a whole, this was neutral, right? So if negative charge went here, positive charge must be here, because right now also it should be neutral. Charge did not go anywhere. So have I charged this body? Did I charge this body? No, because total charge is still 0, right? I've only separated the negative charge from the positive charge. Now the next step is, this is step 1. Step 2, okay, let me explain here itself, right? So step 2 is, you keep this here, you keep this here, keep this here, and you connect this to the ground. So this is called symbol for ground. This is symbol for ground. Now when you do that, this is positive charge. So this would like to spread to the entire surface I told. So this positive charge will run to the ground. Actually what is happening is, electrons, the free electrons in the conductor, are coming up and they will neutralize this positive charge. So this is the movement of your free electrons. Okay, so the movement of free electrons. So the free electrons will come and neutralize this positive charge. Question is, what about this negative charge? Well, this negative charge, we are still holding with this positive charge. So this positive charge is still holding the electrons. Okay, so don't expect these electrons to also leave the ground. Fine. Okay. Now what we do the next step is the second step. The third step, we cut this. So once we cut, this wire is broken. So now these free electrons cannot continue because there is no contact, right? And in between there is air. Air is a nice insulator. Air is a nice insulator. That's why when when you are walking in the road and some electric shocks, electric fire or some electricity is produced in those cables, sparks and all, you don't get affected because in the middle there is air, right? Okay. So now you see, okay. So after this, what you do? Once you have done this, then you remove this. Step 4. You remove this. Then this negative charge, which was concentrated here because this positive charge was holding them. Now the positive charge is not there, and I have told you this negative charge would not like to sit close, so they will try to go as far as possible, and the entire negative charge will spread on the outer surface of the conductor. Okay, let us try to be uniform because I took a sphere, right? So I take a sphere, it should be uniform. Yeah, looks nice now. So this is how this conductor now has become what charge? Negatively charged. Okay, so I did a series of steps, try to revise it, and now try to think what set of diagrams will be in order to make a conductor like this into positively charged conductor. Okay, so give a try to that. Fine. So we have learned how to charge a body through rubbing, through uh, contact. Okay, and now by non-contact. We did not have any contact, remember. And in which step it actually got charged, if you remember, during that time when electrons were coming from the ground to the body, to the conductor. So that was the time when the body was getting charged because new electrons from the ground were coming to the conductor, right? Okay. So shall we see some questions in the material, our EPL? So learning exercise 1 says, when a plastic rod is rubbed with wool, what is the nature of the sorry, some printing mistake is there, nature of charge acquired by the rod. So plastic rod rubbed with wool. So for that you better see your triboelectric series. So wool is wool is quite down, and plastic means basically polyester kind of material. So polyester is even further down. So polyester will become negatively charged because it is down in the triboelectric series, which means that will have more electron affinity. Whichever is more down in that series will be having more love for electrons. So that will become negatively charged. So polyester will become negatively charged. Therefore, the rod will be wool and plastic rod and wool, right? So what's the nature of charge? So wool will become negatively charged. Okay. Let me again see once more. So wool is above, plastic is below, polyester, right? So it will become negatively charged. Sorry, so the rod will become negatively charged. So answer is first question, learning exercise question number 1. First question, it becomes negatively charged. Okay. Second question says, in the above process, do we create any new charge? Did we create any new charge? Obviously, no. We only transferred electrons from one material to other material. We did not create new electrons, right? So we did not. Okay, so types of charging by induction we completed. Now comes the serious topics for your exam purpose. So till now this was all concepts, okay, which is useful for the build up, to build up your theory, your major concepts. These small concepts are important to get it in the mind. Okay, so I hope by now you have understood that charge comes in two flavors. We have positive charge, negative charge as given by Benjamin Franklin, and we know that like charges repel, unlike charges attract. We have seen the value of charge of electron, value of charge of proton. We write the charge of electron as minus E, where E is not electron. Many students know when I ask in a formula what is E, they say electron. E is not electron, E is charge of electron. It is a physical quantity which can be measured. Okay. So all these things we have understood, and we have understood what are the methods of charging. Now comes topics which are very important for your board syllabus. So this topic is very important, and it is called properties of charge. So in exam, basically they ask you write three properties of charge, 3 marks. Okay, three properties basically we need to deal. Now don't write like charges repel, unlike charges attract. Those properties are not acceptable. It should be as per our NCERT textbook. So the first property is called additivity of charge. Additivity of charge. Okay. So if you write a name, it's enough in exam. Additivity of charge. What it means is if a system has charges Q1, Q2. So Q is the symbol that we are going to use for charge. If there is more than one charge, I will write Q1, Q2 like that, right? So I have two charges Q1, Q2. So the total charge of the system is given by the algebraic sum of the two charges within the system. So this is the meaning of additivity of charge. So this sum is not the ordinary sum, it is algebraic sum. What does that mean? That means that if this is negative, this is positive, you should subtract, not add. Okay. So this can be positive or negative, this can be positive or negative. So depending on the sign, we have to add. Okay. So that is the meaning of additivity of charge. Basically, what it means is your charge is scalar quantity. Charge is scalar quantity. Okay. So if you take many people are there, who think that scalars are not negative. That's a very stupid idea actually, because charge is scalar, but it can be negative. So negative is based on what? Convention, right? So if I take time 0 as now, then our birthdays happen at what time? Negative time. So even time can be negative. Time taken cannot be negative because time always increases. So T2 will be always more than T1. So T2 minus T1 will be always positive. The time always increases. But it's not a right thing to say that scalars cannot be negative. Okay? So charge is scalar. And why this concept says charge is scalar is because if you are given two charges and you are asked to find total charge, you are not going to use this formula. Q1 square plus Q2 square plus 2 Q1 Q2 cos theta. This is for vector addition. So this formula is not going to be used. You have to simply add them algebraically. So that's the first property. What's the name of the first property? Additivity of charge. Let us now see the second property. Second property is called quantization of charge. Quantization of charge. So before we go into this, what is this word quantization? Quantized. What does this word quantize say? You may have heard in chemistry in first view. The word quantize is basically opposite of continuous. So opposite of continuous is quantized. Okay, discrete. Okay, countable basically is countable. Okay, you can count 1 2 3. So if something can be counted 1 2 3, it means it is quantized. Example, for example, if I take in a bucket milk. Okay, so if I ask you, is it quantized or is it continuous? Answer is continuous. The milk is everywhere, right? You will not say here milk is there, then here there is milk. Everywhere there is milk, right? In a bucket if you take. So it is continuous. But if you put these milks in small packets, let's say, then you have quantized it, right? You can say 1 packet of milk, 2 packet of milk, 3 packet of milk, right? So this second property says charge is quantized, and this we came to know through the experiment which I told was done by Millikan. So basically what he did, he measured charge on drops of oil, and whatever charge he measured, if I say Q on the oil, was always some integer, was always some integer, okay, okay, 1, 2, 3, 4, 5, like that, always integer times charge of electron in magnitude. So basically what it says is, if I rub two materials, for example, if it gets two electrons, then what will be its charge? If it gets two electrons, minus 2e. If it gets 100 electrons, what will be the charge? Minus 100e. If it loses 100 electrons, what will be the charge? Plus 100e. I can never give you one electron and half electron. So basically this quantization of charge says electron's charge is the smallest charge possible. You cannot further divide the charge of an electron. So basically it is the universal unit of charge. Okay. So keep in mind that quantization of charge says any charge that you measure could be plus or minus, obviously plus or minus, but always integral multiple. What multiple? Integral multiple of the magnitude of charge of electron. This is magnitude of charge of electron. Sign I have written here already, right? So what's the point? Magnitude of charge of electron. Charge of electron, which is how much? This value is how much? 1.6 into 10 power minus 19 coulomb. So this n must be integer. So what will be n from here? Q divided by E. If you want only the number, no need to write the sign. Okay. So n will be Q divided by E. So whether, how will you test whether this charge is possible or not possible according to this rule? Then you just calculate this n. If this n is an integer, it means this charge is possible. If this n is not an integer, this charge is not possible. So as an example, if I ask, is 0.8 into 10 power minus 19 coulomb charge possible in nature? What's the answer? Possible or not possible? 0.8, okay? Is it possible or not possible? So to answer that, do not think too much, just calculate n. So what is n? Q by E. What is the given? Q is the given charge. What is the given charge? 0.8 into 10 power minus 19 coulomb. What is the charge of electron in magnitude? 1.6 into 10 power minus 19 coulomb. What will you get? 0.5. 0.5 is integer? No, it's not an integer. So therefore this charge is not possible. But instead of this, if I write 3.2, is this charge possible or not possible? It is possible, because if I write now here 3.2, I will get 2, right? And 2 is an integer, so that charge is possible. Okay. Uh, Again, little bit detail. Let me try to be here. See, yes, we know that according to quantization of charge, any charge which you gain or you lose must be some integer times charge of electrons in magnitude. However, uh, recently experiments have done, not recently, some 20-30 years back, people have made theories, and now they are more or less proved experimentally also, that there are particles which can have charge less than charge of electron, meaning there can be charges like 1 by 3e, 2 by 3e, okay, possible. This kind of charges are also possible, and we call those particles which have this charge quarks. Quarks. Okay. So how this got its name is quite funny actually. Okay, but again, let us not worry about that. You can read in Google or somewhere. You can. It's very interesting how it got this name. Anyways, so again, the point is, recent experiments have shown that particles which have charge less than charge of electron are present. However, the good news is these charges are within proton, neutron. Remember, I'm not saying within nucleus. Inside nucleus, we have protons and neutrons. Now, inside protons and neutrons, what are there? There are quarks. Recent theories have shown. And these particles have not been observed in a free state. So we don't find these particles like we find electrons roaming in the YS, or here also, right? There are free charges in the air. So we don't find these charges free in the free state. So therefore, no need to worry so much about this violation. Okay, so these charges violate this quantization of charge. Okay, so this is something a little bit detail I wanted to mention to you. Now, let us see the third property. So third property is called conservation of charge. Conservation of charge. So what this conservation of charge says? The total charge of an isolated system remains conserved. Okay, let me repeat. The total charge of an isolated system remains conserved, or you can say constant. It will not change. Total charge of an isolated system. So what do you mean by isolated system? An isolated system is a system through which no interaction is allowed with the surrounding. No interaction. Okay, so let me show you some examples. Statement you have understood, right? Anyways, in exam you have to write only this name. That's enough. Okay. Examples let me give you. Okay, one simple example is there. That rubbing example we took. So you have these two objects A and B. Neutral right now. So charge of this 0. Charge of this 0. So total charge is also 0. So which one I have taken system? These two together. This is my isolated system. I am not going to interact with both of them. But this can interact with this. So I'm going to rub them now. So after I do rubbing, okay, after I rub A and B, that's why I said A is not isolated, because I'm going to rub A with B, right? So how can A be isolated? So once you rub what I have told, let's say this has current, let's say 50 electrons. See, usually millions of electrons will be transferred, okay? But for simplicity, let's say 50 electrons came this way. Then this will have what charge now? Plus 50E. This will have what charge now? Minus 50E. So you can see this was 0. Now it is minus 50E. But this is not isolated. This both of them is isolated, right? Together if you take. So now for total charge of this isolated system, if I take, what's the total charge? Total charge is still 0. So this is a nice example to show conservation of charge. Now let me give you one little fancy example, little interesting but little advanced. Okay. So this, if you don't remember, also it's okay, but better to know, right? So the third, another example of conservation of charge. Okay. So let's say if you take something called gamma rays, then you know that, I hope you know, if you don't know, then you have to wait for some time in physics, second PU, till we reach gamma. In nucleus chapter, we'll be studying them, okay? Anyways, so gamma rays are basically like your light waves, except they are very high frequency. So they are like light waves, but high frequency. So question, what is the charge of gamma rays? If they are like light waves, they are electromagnetic waves only. So what is the charge? 0. Why? Because they are just form of energy, right? They are not made up of atoms. If light had charge, moving charge would be current. So right now I am getting current in all directions. So I should be dancing right now. None of you are dancing, neither I am dancing through the electric shock, right? So gamma rays are chargeless. This is 0. They have energy, but they don't have charge, right? Now, when they come near some nucleus, okay, near some nucleus here in empty space, okay, there is a possibility that somewhere here this gamma ray vanishes. Gamma ray vanishes, it's not there. So this is the system. Before it was gamma ray. Now don't count this as the system, okay, because it's not interacting actually, okay. So this gamma ray comes here and suddenly it's vanished. Instead, what you will see one particle going from here, that is your electron. So this electron came from where? From this gamma ray only. Suddenly it vanished. It vanished and this gamma ray became electron. And what would the charge of electron? Minus. Up till now, you tell me, will conservation of charge, see, this is not so important. This is just for the detail I told. Forget this. So in empty space, this gamma ray can suddenly vanish and become an electron, whose charge is how much? Minus. Now, till here if I say, can this process be allowed in nature? Because we have learned something called conservation of charge. So is this allowed? See, what is the charge of this? 0. What is the charge of this system after? Afterwards it is not 0, because afterwards this electron has a negative charge, minus C. So this process is not allowed because there was no charge, but now you got negative charge for this isolated system. So it is violated conservation of charge. You cannot violate. So what we see is, we see another particle coming out, and that particle is called positron. Positron is a particle similar to electron. Don't call it proton. Okay, proton I know has plus E charge, but it is does not have the same mass as electron. Proton is much heavy, right? That's why electron goes around proton, right? Earth goes around the sun, right? Sun is heavier than Earth. So this is not proton. This is another new elementary particle which we call positron. Okay, and this particle has charge same as electron but opposite polarity. Polarity word again I used. What is polarity? It is that property that distinguishes positive charge from negative charge. Okay, so polarity basically tells you the sign of the charge. So this positron has a charge plus E. It is not proton. Why? Because we want this particle to have exactly same mass as electron. So what is the total charge now after this process has happened? Minus E. This is positron plus E. So total charge 0. So this is another example of conservation of charge. In physics, we call this pair production. Pair production. While doing nuclear physics, okay, in the 12th chapter, I will talk about this in a more detailed way. Okay. Basically, I'm giving you advertisements, okay, to stay with me and this course so that you don't suddenly leave. Okay. Now, the reverse of this is also allowed. So try to see this video which I explained in reverse mode. If you see in reverse mode, what will you see? You will see electron coming like this, positron coming like this, positron, okay? And suddenly here when they meet, they vanish. And what comes out? Gamma rays. So this is reverse video of this one. This is also an example of conservation of charge. No charge before, no charge afterwards. This in physics we call annihilation. Okay, annihilation. Spelling you can check. Annihilation. Okay, so destruction basically. Okay, annihilation. Fine. So I hope you got these two little advanced examples also. By the way, this is a nice example of energy converted to matter. You see, and matter converted to energy. So this is one classic example of which equation can you guess? E equal to mc square. Energy can be converted to mass. Okay, so once we are done with this, now we have one entrance topic. Okay, so we are going to now discuss one entrance topic, and I will follow the same rule. Anything I will do under hashtag. Okay, if I write this hashtag, then any topic I do is under your entrance topic only. So no need to see that for your board syllabus. So under this entrance topic, there is a very interesting fact. Okay, you know that. So what I want to show you is repulsion. Repulsion is the surest test for presence of charge. So whether a body is charged or not, to test repulsion is the surest test, not attraction. Let us understand why. Okay, so let's say I have two bodies. Okay, two bodies, they have atoms inside, and let's say this is positive and this is negative. So what will happen? Attraction. Okay, now if I have positive, positive, what will happen? Repulsion. If I have negative, negative, what will happen? Repulsion. Okay, now see this. Suppose I have positive and neutral, no charge. Then what will happen? You may be thinking, oh, neither attraction nor repulsion. But mind you, I explained to you something called how the scale attracts those pieces of paper, even when the pieces of paper were neutral. Yes or no? So, if this is positive and this is neutral, what will happen by this process called polarization? This plus will attract the minus this side, and this side will become plus. So, minus is nearer to plus than this plus, so it will be attracted. So even if this body had no charge, it is still attracted. See? So just because a body gets attracted to a charged body doesn't mean the first body has opposite charge. Remember, a neutral body can be attracted to positive charge. What about what if I bring negative body, neutral body and negative body? What will happen? This negative will induce positive charge here and negative charge here. Which is nearer? Positive charge is nearer. So again, this will be attracted. So if a body gets attracted, you are not sure that it is charged. It could be neutral also, remember. But if a body is repelled, like here or here, then 100% it means it has same polarity charge. Okay, so keep that in mind. This is something we will be using to solve questions from our entrance corner. So after learning some concepts, it's time to see some questions. Okay, so exam corner 1, question number 1. Is a charge of 0.8 into 10 power minus 19 coulomb possible? No, we have already studied no. If a charge Q1 and Q2 satisfy the following relation. First relation is Q1 into Q2 is less than 0. And second relation is Q1 into Q2 is greater than 0. Then what is the nature of the force? If the product is less than 0, it means this product should be negative. That means if this is plus, this should be minus. This is minus, this should be plus. So that means the nature of the force between these two will be attractive. So attractive is the answer for this part. If the product of two charges is greater than 0, then it means what? Either both are positive or both are negative. Minus minus is also plus, right? So therefore the nature of the force will be repulsive. Okay. Third question, let us see. This is interesting. On a macroscopic scale, can we consider charge continuous? Now I have told you charge is quantized. We have spoken already that charge comes in integral multiple of charge of electron. Right? 1e, 2e, 3e, like that. You can count. So it is quantized, not continuous. But they are asking on a macroscopic scale. So on a macroscopic scale, okay, can we consider charge to be continuous? Answer is yes. Yes, we can consider charge as continuous. On a macroscopic scale, charge can be considered as continuum. As continuous. Matlab you can forget about the quantization of charge. Continuous. Okay. And why is it like that now, sir? Before you told charge is quantized, now you are saying charge is continuous. See, if you want the fact answer, then it is quantized. There's no doubt. But on macroscopic scale, they told, right? So macroscopic scale here means when you rub your scale on the hair. Okay, you're not talking about how many electrons are there in carbon atom. So when you say that, you are not talking about macroscopic scale. You're talking about microscopic scale. So in that case, yes, you have to count 1 electron, 2 electrons, 6 electrons are there. But when you talk about macroscopic scale, daily life experiments, when you do like rubbing scale on hair, okay, then what happens is so many electrons participate. Okay, the charge that we deal with in our daily life will be like 1 microcoulomb and all. Now 1 microcoulomb is huge compared to charge of electron, right? 1 microcoulomb is how much? 10 power minus 6 coulomb, right? So charge of electron is how much? 1.6 into 10 power minus 19. So if you forget this 1.6 also, The order of charge of electron is how much? 10 power minus 19 coulomb. So this is 10 power 13 times larger than charge of electron, approximately. So when you deal with large charges that we have in our daily life, the small differences from one electron to another electron, that difference doesn't matter. Okay, so if you have too many hairs in your head, like I have right now, okay, because of this bun I'm not able to cut hairs also. So if you have so many hairs, then the one hair, two hair, that doesn't matter, it looks like continuous, right? So I think I have given you a nice example, right? So try to remember that way, that when we talk about continuous charge, you can forget about the discreteness of the charge due to the discreteness of electrons. Okay, fine. Next question is question number 4. Ordinary rubber is an insulator, but the special tires of aircrafts are made slightly conducting. Why is this necessary? So if you take the tires of aircrafts, okay, they are made slightly conducting. So we will coat them with some metallic liquid. This is slightly conducting. Slightly conducting. Why they are asking? Well, the answer is, as this aeroplane runs through the runway, as it moves through the runway, these tires will rub against the floor. So as it rubs, it may acquire static charge, right? We have discussed. It will accumulate charge. And as the charge accumulates, there is a possibility that the air nearby may undergo something called breakdown. And when that breakdown will happen, this charge will suddenly leak to the ground, and that sudden flow of charge into the ground will create a spark. And that spark, if it is much higher than than the safety values, then it may result in fire. So for this purpose, we make this slightly conducting, so that whatever charge accumulates to the tires will run to the ground. So it continuously keeps running to the ground instead of suddenly flowing out into the air if the air becomes conducting. So let me try to explain this a little bit detailed. See, air is usually having your steady base, right? So your H2Os and all some bond angles and all. Please don't ask me, okay? Ask Praveen sir or Kiran sir, okay? Some bond angles are there. H2O. Oh, I spoke about water vapor only. So there will be oxygen also, right? Then there will be nitrogen, whatever. So these are neutral molecules. Okay, number of electrons inside and number of protons are equal. Now imagine here is a body which is getting charged. Now if it becomes plus charge, so this is neutral. See, these air molecules are neutral, so the whole air is nice insulator. There are no free charge to flow from one place to another place. Okay, but if you accumulate charge in some region, then say what will happen. This plus will attract the minus charges here, this side, and this plus will repel the plus charges that side on the far end. So the whole thing, this molecule will have on one side negative, one side plus. Now if I keep increasing the positive charge here, I keep increasing more and more positive, then what will happen? These electrons here will get more and more attracted, and the positive charge will be more and more repelled. So it's like it's like putting in class I give this funny example. It's like putting your legs on the stomach of somebody, and with your hand you are pulling the hair this side. So you pull the hair this side, stomach that side, right? So chances are, what will come out? The stomach will come out of the body, or the hair will come out. The hair, because that is weakly bound compared to the stomach area, to the remaining part of the body, right? So the electrons here, which are more weakly bound than the protons, they will be removed uh, from the molecule. So this is called ionization. So if the accumulation of charge here is exceedingly high, then it will create such differential force on different parts. Differential here means some part will be attracted more this way, some part will be repelled more that way. So as that happens, if that shearing forces increases, chances are the molecule will get ionized, and then everywhere there will be lot of free electrons which can suddenly it will jump to this positive charge to neutralize this. And if the electrons jump into this means what, this plus charge has been neutralized. Another way of saying it, this plus charge went out, and that's how it got neutralized. And during this sudden flow there is a possibility that sparks and all may occur. Okay, so we have a name for this, we call this corona discharge. Corona discharge. So when a body keeps accumulating charge, there is a chance that the surrounding air may become conductive, and then this charge will discharge. This charge will leak, and that in that process there is a possibility that sparks may occur. So you have also seen, when trucks and all move, which carry inflammable materials, petrol and all, if they carry and move, they will have some, so this is the truck, okay, how the front part will look, something like this, right? Okay. So if they are carrying some cylinders with petrol and all, then you'll see in the back, some chain will run to the ground. So that is making sure that any charge, as this truck is moving, air is rubbing it, right? Air is passing by, so it may, the body may get charged, and if that happens, if the charge exceeds too much, then it will create sparks, which I mentioned. If that results in a temperature more than the ignition temperature of the petrol or the vapors here, then it may catch fire. So for that, what we do, we make a metallic contact with the ground, so that any charge accumulates will run to the ground through the wire, and therefore this will never get chance to accumulate charge. Okay, let's see the next question now. Question number 5. A comb run through one's dry hair attracts bits of paper. What happens to the if what happens if the hair is wet? So if your hair is wet, then what will happen? There will be less friction, so the rubbing will not be proper, and therefore the bits of paper will not be attracted. Okay, so the answer is the bits of paper will not be attracted. Bits of paper will not be attracted. All these questions are actually not asked in board exams as such, but still, okay, it may be asked someday, or it's always good to know all these things. Next is, what does Q1, question number 6, what does Q1 plus Q2 equal to 0 signify in electrostatics? So this signifies that charges are scalar, right? First thing. So when you add them algebraically, and it signifies one has opposite polarity than the other. So if this is positive, this is negative, this is negative, this is positive. Okay. It also signifies the additivity of charge. So any one property, whichever I mentioned, you can write. Now next is entrance corner, but then so the time is up for today. So I'll see you in the next video, I should say, not class. So again, be safe, and let me just take 1 minute now to say you something. Okay, for the remaining videos now, what I'll be doing is, the class is for 1.5 hours. Okay, for physics subject, and I'm sure for other subjects also. So what I'm going to do is 1 hour, 1 hour, or sometimes 1 hour 15 minutes, I'll be teaching you whatever is there in EPL and all. Remaining 15 minutes I'll be using to solve doubts of students who keep messaging me. Okay, first few they are revising. So whatever doubts come, and I feel like these doubts are important for all the students to know. So remaining 15 minutes like that I'll be using to solve those questions, which will be like doubt clarification. And if you have doubt in the topics which I've taught, mention in the comment, or you can message me if you have my number. I will be discussing that in the next video. So be safe and see you.